Okay, so today we're going to look at differentiating the natural logarithmic function. Now the natural logarithmic function is log of base e, okay? That can also be written as ln, which is standing for the natural logarithm. We're not going to be differentiating other functions such as log of base 2, log of base 10, or anything else, okay? That's not part of the study design, and we would just use CAS to differentiate things like that if needed. Okay, so once again, there are proofs of this rule in your textbook, should you like to know. We're just going to focus on the rule itself. Now, the derivative of log e of x is actually 1 over x. But the better rule to remember is that if we're differentiating log base e of a function, what we get is in the numerator we have the derivative of that function, and in the denominator we have the function itself. So if we are using this rule to apply to our first example, our first rule there, well, we differentiate the function, we differentiate whatever is inside here. The derivative of x is indeed 1, which is what we've got here, and then we write it over the function itself, which is the x. Okay, so looking at our example here, so our rule, if you recall, is that if we are differentiating log base e of a function, and this formula is indeed on your formula sheet, what we get is the derivative of the function over the function itself. So to find dy dx, we're going to have a fraction. In the denominator, we keep the function as it is, 7x squared plus 5x. In the numerator, we differentiate this function. The derivative of 7x squared is, we multiply by the power, 7 times 2 gives me 14x, plus the derivative of 5x is 5. You can look and think, is it possible to cancel, to simplify? But hopefully you'll notice that no, it actually is not. Of course, we cannot cancel the 5's because for each, the numerator and the denominator is a term altogether. Now, our second example is a little trickier because we have this x plus 1 over x minus 1. This is difficult to differentiate. We don't know the quotient rule yet, so we can't differentiate this. However, we can use our log laws. Remember, our log laws say that when we are dividing within a log function like this here, that is the same as saying log base e of x plus 1 minus log base e of x minus 1 of the denominator. If you've forgotten those log laws, feel free to look back at some of the earlier videos to revise those laws. So now, to calculate the derivative, and because our original function was given as f of x, that means our derivative needs to be in that form of f dash x, using that same notation. So the derivative of the first part, okay? So we're differentiating this first part of the expression. The derivative of log base e is a fraction. The denominator is the function itself, and in the numerator we write the derivative. So the derivative of x plus 1, derivative of x is just 1, derivative of 1 is 0. Then we get to the second part of our function that we're looking at, so we subtract. We're now differentiating our second log. The function itself, x minus 1, belongs in the denominator, and the derivative of the inside part, the derivative of x is 1, the derivative of negative 1 is 0. And that's it. That's the final answer. There is no need to go further. There is no need to write a common denominator unless you happen to need to for a later part of the question. That is the derivative. If we are looking at a more specific example, like this one here, when we're trying to find the y-coordinate and the gradient of the tangent to the curve. So if I'm wanting to find the y coordinate first, where x equals 1, so I can just substitute that in. When x equals 1, y would equal 1 plus log base e of, instead of x I have 1, 2 times 1 is 2, plus 3, and that is squared. So I get 1 plus log base e of 5 squared, which is 25. And we can write our answer like this, or there are multiple other ways that we could simplify it. But, or not simplify, multiple other ways that we could express our answer, although none are simpler than that one. To find the gradient of the tangent at that point, remember when we're talking about the gradient, that means that we're talking about finding the derivative, of course. You need to get used to in your head when you read the word gradient that you think derivative. So our original function was given like so. Log base e of 2x plus 3, and that function is squared. Now we are going to use a whole lot of different techniques in this. So we differentiate, okay? The derivative of x is 1 plus the derivative of log e of x. In the denominator, we just write the function itself, 2x plus 3 all squared. Now we come to the tricky part. For the numerator of our log, what we need to do is to differentiate the inside function. If we are differentiating this function here, we need to use the chain rule that we learnt earlier. And this is where using the shortcut of the chain rule can be easy. Rather than setting up your u function, let's remember the shortcut, which is that we work out the outer derivative and multiply this by the inner derivative. So the outer derivative, that means I multiply by the power, which is 2. I keep the inside as is, and I subtract 1 from the power, giving me 1. I multiply that by the inner derivative. The derivative of 2x plus 3 is just 2. We can actually do some cancelling out here, because if we have a look, we can notice that our numerator has all just been multiplied together. So this bracket here, 2x plus 3, can cancel out with one of our brackets here. What this is going to give us then is an answer of 1 plus, in the numerator we have 2 multiplied by 2, which will give us 4, over, in the denominator, 2x plus 3. We can't simplify it anymore. We could express as a whole fraction if needed, but that's not necessary. The question was to find the gradient of the tangent to the curve where x equals 1. So we then need to substitute in when x equals 1. And our derivative will then become, or the gradient will then become 1 plus 4 over 2 times 1 is 2 plus 3. So 1 plus 4 over 5. That's not a nice way to give our answer. If we were to write this as a mixed number, that's the same as 5 over 5 plus 4 over 5, so we get 9 over 5 as our final answer. When we're doing these questions, we do need to put everything in together, but once again, refer to the formula sheet if you forget, so that you're able to work out the derivatives that we're looking for.